All right, yo. Um, yeah, it's been a long time since I've last recorded. I just got so busy with school and everything. Um, but I have been working diligently, just haven't been recording anything. Um, but we're back, and I've been trying to get my C++ up for the last little while. I've been going through this textbook called Scientific and Engineering C++. But yeah, so I'm on chapter 4 now, getting through the exercises, and right now I'm on point 4.5. So yeah, so we are currently dealing with a couple classes that we made following the book's chapter, where we made a class for points in 2D initially, and a class for making lines class, so a line object and a point object. And the point class allowed us to first initialize a point, calculate the distance between 2 points, then also calculate the angle, which this was one of the chapter problems where we had to calculate the angle between 2 points, and also moving to a point, so from one point to another. So that's the point class. And then the line class, line object, we initialize a line given in two different ways. So first way is given 2 points P1 and P2, and there's two main ways to initialize that type of line. First one is if you're given a line that's just parallel to either the x, y, or z axis, then we can construct a much simpler line. Okay, I'm working on this in 3D now, and it's a little bit more complicated making this in 3D, because suddenly the ax plus by plus c z plus d equation, this is actually describing a plane. So I don't know if we're supposed to move to a more parametric, to the parametric definition of creating a line. But I found this resource online. Oh, I did not start that. Found a resource online that might be useful to us. So that's the first way of making a line. And the second way is constructing a line through P, so through a point that is tangent to a given tangent to this given 3D slope. So we have to, this is also on the to-do actually, and then it's fine, you can walk through it. This is also to-do because we're a little stuck. So I don't want to use any ChatGPT for this. I'm totally fine using Google, because we're not here to create, we're not here to just push out and finish these problems for somebody. This is all for us. So what's the point of using ChatGPT? I'm not on a deadline here. But this is also on the to-do because we basically were given all these objects in 2D from the textbook, and our most recent problem is to redesign the point and line examples in this chapter for 3 dimensions. So in 2D it was pretty simple, but now we have to go into 3D, and we might have to explore more ways of describing a line in 3D. Yeah, the point class is finished pretty much. That was not bad at all. Just had to make a separate like cross product length of the cross product function, which was very simple, and to calculate the angle between points P1 and P3, with like point P2 being like the middle, like P1, P2, P3, that angle. So yeah, so let's get into it. So the line equation, the equation of a line is defined with two known points, same as us. This page describes a line equation using the parametric form. A point P1, a line in direction V, vector V of the... Okay, so this seems to be more in line with the second way of describing the creating a line. I don't think we'll be able to make a line with just 2 points anymore in 3D, but we'll see. I don't want to block myself off right now. The direction vector can be computed by subtracting the two known points. Okay, so we can do this given 2 points. Therefore, the parametric form of the line equation is line is the first point plus the parameter t times the direction vector. Okay. Or each element xyz of the line can be written by the parameter t. Notice that it is the same linear interpolation on each axis. If t is 0 to ranges from 0 to 1, it is an interpolation, otherwise extrapolation. Also note that 2D line equation is frequently represented with slope-intercept form y equals mx plus b, or standard form ax plus by plus b. But these forms are not suitable for computer algorithms because the slope of a vertical line is undefined. And plus, the slope-intercept form cannot be used in 3D space. You know, considering that I'm a math major, it's very embarrassing that I don't know these things off the top of my head, and I was trying to pretty much extrapolate this version of the line equation to 3D, but I didn't know that. I didn't realize, I knew, but I didn't realize, I learned this before, that this in 3D describes a plane. So, okay, so we can make a... See, I don't want to use a point class to make a direction vector because that will... that muddies the definition of point because direction vector is not a point. See, I have a point class. What if I have to make a vector3 class that is the parent to the point class, make the point class a subclass of vector3? That sounds like a lot of work. Okay, vector3 point line point 1 point. Okay, so we establish so we're given, we have a point, we have direction. Oh, yeah, man, why is this? Can I use the point class to make a direction vector? But then you do weird things like calculating the distance between 2 points, which doesn't make sense if you're making a direction vector. Okay, you know what? We're just gonna call it we're gonna make a point. You're gonna use point to make a direction vector. That's how it's gonna be. Or we just use this. Honestly, we just use this. This is fine. We forget this part. Now we need a way to store this data somehow. Direction data. Can I do this? The P2, yeah. I'm so stupid. So I guess the line data is stored as 2 points. So I guess we have to live with. Mm. Uh, yeah, I don't know. We gotta make these point and direction point objects private member variables. Oh, I don't think I have these. There we go. We don't have cross. How do you make a prototype function? Hmm. All right. I think we're gonna wrap it for today, but we did make some good progress, so I'm happy. All right, yo.